In this video, we will explain Newton's second law of motion. Newton's first law tells us that forces change the way things move. Forces produce accelerations. The second law goes into a bit more detail about the relationship between the size of the force and the amount of acceleration and the object being pushed. We can think of Newton's second law as basically saying two things. Let's look at the first one. We know that forces accelerate the objects they act on. Forces change an object's motion. Newton's second law tells us that the acceleration is directly proportional to the size of the force. What does that mean? It means the bigger the force that's pushing something, the greater will be the object's acceleration. More specifically, if we were to push twice as hard, then the object would accelerate or change its velocity at twice the rate. If we increase the force by a factor of 10, the object would accelerate 10 times faster. If we halved the force, the acceleration would be halved. We've seen this situation before. A car that gently brakes and slows from 100 kilometers an hour to 0 over a fairly long time, that's a small acceleration, which means the force that was slowing the car down was reasonably small, and the force that was slowing the occupants of the car down was small. That's not going to hurt you. Our second car changed from 100 kilometers an hour to 0 in a very short time. It had a very large acceleration, which meant the force that was slowing it down must also have been very large, and the force that was slowing down the occupants was very large. If something pushes gently on you, you might not like it, but you won't be harmed. If a very large force acts on you, that can do serious damage. And that's why the occupants of a car that crashes into a wall at high speed are more likely to be injured than one that brakes gently. The slower the rate of change of motion, the smaller the force that's changing that motion. And if the force that's slowing you down is small, you won't be hurt. If the force that's slowing you down is very large, you will be hurt. So, Newton's second law tells us forces change motion. We already know that. But the greater the force, the greater the rate of change of motion. The greater the acceleration. Bigger forces produce bigger accelerations. Here's a question for you. True or false? A force is accelerating my spaceship, making it go faster. If the force is doubled, the ship will go twice as fast. Is that true or false? If necessary, pause the video and think about it for a moment. The answer, of course, is false. The force is proportional to the acceleration, the rate at which the motion changes, not how much the motion changes. When you double the force, you double the rate of change of the ship's velocity, its acceleration. So, for example, if the ship was originally speeding up by 10 meters a second every second, then if I double that force, that will cause it to speed up by 20 meters a second every second. Doubling the force doubles the rate of change of motion. Will it end up going twice as fast? Well, that depends on other things. How fast the ship ends up going will depend both on how hard I'm pushing it, but also how long I push it for. As long as I'm pushing it, it's getting faster. If I only push it for a very short time, it won't get very much faster. If I keep pushing it for a long time, it will keep getting faster and faster for as long as I push it. The point here is that the force is proportional to the acceleration, the rate at which the motion changes. Changing the force changes how quickly the motion changes. How much the motion changes, that's a different thing, and it depends also on how long I keep applying the force for. The second part of Newton's second law has to do with the object that we're applying a force to. It says that the effect of the force, the acceleration, depends on the mass of the object it is acting on. The larger the mass of the object, the less effect a force is going to have. So if you apply the same size force to a large mass and a small mass, the large mass will have a smaller acceleration. It won't change speed at the same rate. It will change speed at a fairly slow rate. The small mass will have a much larger acceleration. It will change speed at a faster rate. The larger the mass of the object, the less effect the force has. So here's another question. The force is accelerating Mary's Mini. The same size force is accelerating Fred's fire engine. If you were watching those two take off from a red light, what difference will you see in the motion of the two vehicles? Again, you can pause the video for a moment while you think about it. We said that the effect of a force depends on the mass of the object. The same force will have less effect on heavier objects. Since the fire engine has more mass than the Mini, it will accelerate at a slower rate than the Mini. So what you will see is the fire engine will speed up at a slower rate. So for example, if the Mini sped up by 4 meters a second every second, the fire engine might only get 1 meter a second faster every second. Because it is a larger mass, that same size force causes it to accelerate more slowly. Again, they will probably both end up going the same speed, whatever the speed limit is on that road. It's just that the fire engine with the larger mass will take longer to get to that speed. So summarizing Newton's second law, we know that forces change motion. That's Newton's first law tells us that. The bigger the force, the faster will be the rate at which the motion changes, the faster the acceleration. The larger the mass of the object the force is acting on, the less effect that force will have. The smaller will be that object's acceleration.